This is how we fill out our table for the abiotic data we have up here for a rock platform. I'm going to use red pen so you can see it, but you should use blue or black pen, or preferably pencil, so you can rub things out rather than use whiteout. The table here is distance from the low water mark, LWM, and here is LWM here, and it starts here at the sea. And then as we go up the bank or the shoreline, we have rock pools up to a cliff here. The first distance is at position location A, and it is 15.4. Where do they get that from? Well, take it from this mark, and because this is where the 0 is, and we use a ruler to move down. We have 15. Each graduation is 2, because we go 2, 4, 6, 8, 10, so 15 and to 16. And if we line up that arrow, we are at 15.4, and that's where they get that mark there. Salinity is grams of salt per litre of water at location A. S is salinity, and it is 41 grams per litre, and there it is there. Put that in the table. Location A, temperature is 26 degrees Celsius, and the oxygen concentration in percentage is 19%. We are now going to look at location B and use that data to enter into our table. So distance from the low water mark, we get our ruler and we follow the arrow line down, and we're just past 12 and we are at 12.4. So we write that in. Next is the salinity. At location B, salinity is 38 grams per litre, so we just write 38. The temperature is 26 degrees Celsius still, and the oxygen concentration is 28%, and we just write 28 in the table there. I finished my table, and next I have to create a couple of graphs. The first two is a line graph showing distance from the low water mark on the x-axis and salinity on the y-axis, and distance from the low water mark again on the x-axis and temperature on the y-axis. So I'm just going to plan out the scale of my graph, and since distance from the low water mark is going to be on the x-axis, I'm going to have it down here, and I'm going to have one y-axis for temperature and the other one for salinity. Now, to decide on my scale for each axis, the scale for my graph, because I'm not going to use this, I'm going to use the grid paper on this side, I have to consider the ranges of my data. So the range is the lowest value to the highest value. Okay, so the distance from the low water mark, it's this data here. The lowest value is 0 and the highest is 15.4. So my range is 0 to 15.4. So on my graph, I think I want to go up to 16, 0 to 16, just a nice round number. Now, for temperature, here's my temperature here. My lowest is 15 degrees Celsius, and the highest is 26 degrees. So on my graph, I might go from 10 to 30, and that's nice round numbers there. Salinity, my lowest is 34 grams per litre, and the highest is 41 grams per litre. So I might have a scale going from 30 to 50. So I've been looking at my ranges for the data, and I'm deciding what scale I'm going to use, and I'm looking at the graph paper that I'm going to draw these graphs on. Now remember, one of the rules of drawing a graph is that your graph has to take up more than 2/3 of the grid that you're offered. So with distance to low water mark, I've decided that my range is 0 to 15.4, so my scale is going to be 0 to 16, and if I get my ruler down the bottom there, because low water mark, distance to low water mark is in meters, and it has to be on the X scale. There's about 16, so 0 to 16, so that fits quite nicely. That means that I will use 2 squares. 2 squares will equal 1 gram per litre, so I can draw that in now. And I can put the graduation marks in. 0. And here it is. I finished putting in all the markers, and I've labelled it. I've put the axis a label. That is really important for earning marks. Distance from low water mark, and the units, which will be in meters. So temperature needs to be on one of the y-axes, and my range was 15 to 26 degrees Celsius. So I'm going to decide to make the scale between 10 and 30, and that will cover all the data. There's a difference of 20 degrees Celsius, so I think that if I get my ruler, that 2 squares is roughly 1 centimetre, and if I go up, use 2 squares for 1 degree Celsius, it'll come all the way up to here, which fills my graph up nicely. So I've drawn one of my y-axes for the temperature, and as I said, I'm starting at 10 and I'm going up to 30, where 2 squares is going to be 1 degrees Celsius. It's really important, if you're not starting at 0 and you're starting at some other number, that you don't call this 10. You actually start what would have been 0 and you make that the 10, and you label it as 10, because the next two squares will be 11 and so forth. Now considering my other y-axis, so remember, if you forget what x and y axes are, you can remember that you run across something, so across x, that's going to be the x-axis, and y is always the vertical, y high in the sky. So salinity, my range was 34 to 41, so I had decided that I was going to do between 30 and 50 grams per litre of water on my scale, and that's again conveniently a difference of 20. So again, I will use 2 little squares to equal 1 gram per litre of water. So now I've put in my salinity scale, and very importantly that I've started 30 where I would have put 0, and then I've gone up by ones. I've put my label in and the units that scale is in. And I'm going to plot temperature first. So here's my temperature scale, here's my distance from the low water mark, Now, at distance of 0 from the low water mark, I have a temperature of 15 degrees. So, distance of low water mark at 0, so when low water mark distance is 0, the temperature is 15. So I just come up here, and I'm still on the axis, and I'm going to put a cross as the temperature markers. Next one, distance of 1.9, so almost 2, not right on 2, just less than 2. The temperature is 17. So I'll make sure I stay there, 14, 15, 16, 17, and I put a cross there. Next one, distance from low water mark, 5.6. So there's 5.5. So 5.6 will be just a little bit past it. And the temperature is going to be 20. So I'll make sure I stay there and I'm right on the 20. I've plotted my temperature and now it's time to plot salinity. So at distance from the low water mark 0, the salinity is 34. So, and I'm using this scale this time because this is my salinity scale. So 0 distance, salinity has got to be 34. And instead of crosses, to be different, you don't have to use different colours or highlighters or whatever, just use a different symbol. So I use crosses for temperature and I'm going to use circles for salinity. 0, 1.9, the salinity is going to be 35. So I say it's 35 and 1.9 is just below 2. Salinity is going to be 36. 5.2 will be there. Now remember, we were asked to make a line graph, and this is a line graph. We've plotted our points and I have joined the data points. I haven't extended the line. Sometimes you'll be asked to draw a line of best fit, and that is a trend. That's not what we're doing now. We're just showing our data on a line graph. Now, because I've used two different y-axes and different data points, I have to provide a key. So I've provided my key. Again, crosses are temperature and circles are salinity. And I decided my title is going to be Graph Showing Salinity and Temperature in Rock Pools at Distance from the Sea. So that gives context as to what it is. And graphs are a lot easier to see trends and relationships between variables than just looking at a table. Looking at the graph now, we can see that as you increase in distance from the sea, both the temperature and the salinity increase.